purpose of this video is for you to be able to state the Doppler effect and explain its causes and effects. Before we begin with the Doppler effect, there's some important terms that you need to be aware of and that are going to be used. They're probably going to be reviewed. One is a wave source or a source. And a source is anything that's making a wave. In this picture, it's the crow yelling, caw, caw. There's an observer, and that's whoever experiences the wave. There are lots of observers in this picture, but we're just going to focus in on this person. And then there's the symbol. Another key term is nu. And that's this letter, and nu stands for frequency. Now, let's pretend we had a fire truck. All right? And the fire truck's not moving. This would be the source. And then this person, Dr. Square, is an observer. They're experiencing this frequency, as is Crazy here. That's the frequency that they're going to hear from the siren of the fire truck. Now, when you have movement, let's pretend the fire truck is moving to the right. Moving to the right, what's going to happen to the waves is the waves get crunched together in the direction of the motion, and behind the motion, if the waves are also produced in a spherical way, they get spread out. Now what this does is it changes the frequency that the observer witnesses. For example, the person in front of the wave, Dr. Square, he would see an increase in frequency, whereas Crazy here would see a decrease in frequency. Now, let's explain this piece by piece. Here's the example right above it. So we've got the person. We've got Crazy here. That's this person here. What was this change in frequency? It went down from 700 hertz to 690 hertz because the truck was moving away. So the source was moving away. Now the other person is Dr. Square, and Dr. Square saw frequency increase or pitch increase from 700 to 710 because the source was moving towards him. Now here's another example. Let's say you're on this object's on a diving board. And let's say that's the frequency of the crow. And let's pretend that the crow is kind of hovering. If the wind's hitting it just right, because there's only one bird that can really hover, but in this scenario there's a bird. Excuse me, the crow is hovering, and because the wind's hitting it just right. There's no change in the frequency because nobody's moving relative to each other. The crow's staying put, and so is Circle Person. Now, when he jumps off and goes down, now he's moving towards the crow to a certain extent. The pitch would increase a little bit because he's moving towards, Circle Person's moving towards the crow. And when he goes below it, he's going to notice a slight change in pitch, and it's going to go less than what it was at the start. So the frequency would decrease in that example when he's moving away from the crow. Now, here's the definition of the Doppler effect. It's the observed change of a wave's frequency due to the source's or observer's motion relative to each other. The word relative is important in this scenario because things could be moving and they're not moving. They could be keeping the same distance from each other, so you wouldn't witness the Doppler effect. Perhaps circular motion is one thing, and basically the only time when things are moving, not moving, but not relative to each other. They're keeping like the equal distance. Now, this applies to all waves. For example, light. Light also will exhibit the Doppler effect, even though it's something it's not a physical thing, but it'll still experience it. The amount of shift depends on a source's or observer's speed to each other. The more the speed, the more the shift. And if you go back to this example, if the truck had been moving twice as fast, these numbers would have changed more. It would have been 7015 and 680 or something like to that effect. Now, and the last thing is that it affects wavelength too. As the pitch increases, the wavelength goes down, or as the frequency increases, the wavelength goes down, and as the frequency goes down, the wavelength goes up. Now, so the Doppler effect, the cause of it is that it's the movement of the observer or source relative to each other. They're either moving away or they're moving closer. And the effect is that the observer experiences a change in the wave's frequency. A fun fact is this is the source for the actual frequency of crows. They seemed, based upon that source, that their optimal sound frequency was between 500 hertz and 2 kilohertz.